Hello everyone, today we are going to discuss how do GPT-4 compare to Google Cloud's API library. We're going to talk about performance comparison on different SEO tasks. These tasks are split into different groups like understanding text or even turning content from one form to another. We're going to put the two different APIs from the two categories one against the other, and we're going to discuss the benefits and limitations of using each one. My intention with this video is hopefully to show you that GPT-4 and ChatGPT are not the only answer to most of the SEO tasks that you're trying to automate. I want to inspire you with this video to think creatively about the available machine learning models and APIs and how you use them in your day-to-day. I also want to help you understand the different areas where machine learning based automation can actually help you boost your efficiency and improve the outcomes of the analysis that you're doing when it comes to analysis done in digital marketing. And I also want to illustrate the importance of choosing your automation allies carefully depending on the task, as opposed to just relying on one solution like GPT-4 or ChatGPT for all of your automation tasks just because it is the hot popular model. And of course, throughout this process, we're also going to see aspects in which large language models like GPT-4 actually outperform some of the APIs that Google Cloud has. I also want to say that I'm extremely excited to say that a much more detailed version of this video is available as a blog post. My first actually publication with Search Engine Land. Definitely click on the link in the description and see the full blog post on their website, because it will contain a lot more information about the tasks that we are going to be putting the two APIs head to head. Despite the fact that we're going to discuss Google Cloud in this video and the APIs that they have in their library, there's also equivalents from Microsoft Azure and from AWS, and these three tech giants have been creating APIs for digital marketers, for marketing analysts, for probably the past couple of decades. And I believe that these are not widely known and widely spread in terms of their use and applications in the digital marketing and SEO communities, but that doesn't mean that they are not good. In order to test the performance of the models that I will mention in this video, I've put them against one another on the same data, whether that is textual data, videos, audio, or images. That all depends on the tasks that we will be evaluating them for. And I've repeated this process for 3 different data points for each of the assessments that we're going to do. There will be future videos on my channel that provide a much deeper insight into how to do the specific tasks and what this kind of performance analysis looks like. So subscribe and stay tuned for those videos. But within this video, we're only going to talk about the performance comparison summary from the analysis that I've conducted and my notes on the process, how easy it was to set up, and also the results and how satisfactory they are within the context of digital marketing and SEO. A very common task in digital marketing and SEO is understanding unstructured text. This will be the first category where we're going to put the APIs head to head. Speaking about understanding text, very frequently we have the task of entity recognition. Named entity recognition is an area in computer science and natural language processing. It focuses on detecting and categorizing specific entities in a text, and this could be people's names or organizations or places, things like that. The main objective of this type of analysis is to efficiently extract entities and details from unstructured text, otherwise from free-form text, anything that you can see in a blog post or a YouTube video description or anything like that. Another task when it comes to understanding text is syntax analysis. So syntax analysis or syntactic analysis is a very fundamental aspect of NLP. It deals with understanding the structure of language, which could mean how sentences are structured or what specific forms of language are used. Check out the blog post to see examples of the specific tasks that are involved in syntax analysis. Both entity analysis and syntax analysis are, I would say, quite important for SEOs to implement in their strategy. And there are several different projects that you can use either of these analysis in. I will quickly mention just some of the projects where you can implement entity analysis. I will have a future video on this topic that will detail different projects that you can use entity analysis in, so definitely stay tuned for that one. You can use entity analysis in SERP analysis by extracting entities from titles, URLs, or meta descriptions of the pages that are ranking for your set of target keywords. You can also use entity analysis in keyword research. Starting with your keyword universe, you can extract entities from the keywords that you have already selected as important, see which ones contain entities and which entities are actually important for the topic that you are trying to build content in. You can also use entity analysis in internal link audits by analyzing anchor text. I also have a video on this that you can check out. And you can also use it in competitor analysis and analyzing social comments from sources like YouTube comments, social media mentions, or anywhere on the web that your brand is mentioned, just trying to extract the main entities that people are talking about. When it comes to syntax analysis, you can use syntax analysis to analyze content at scale, which can allow you to understand which sentences and sentence structures are most frequently used. You can identify n-grams and implement other fuzzy matching techniques, like when it comes to redirections or analyzing anchor text for your internal links or even backlinks. You can also use syntax analysis to determine successful title structures whenever you have textual data for the titles that you're analyzing and also their ranking. You can insights to determine what ranks best for your niche. So now let's talk about the model that you can use to analyze entities, Google Cloud Natural Language API. So the benefits of using this API is actually that it recognizes entities and it provides a score for the entity's prominence and importance, and it also provides the number of mentions of this particular entity within the text that you're trying to analyze. Another benefit is that this particular API also has a module that you can use to do syntax analysis, which includes part of speech tagging and building dependency trees. It is very scalable. It also has a model for sentiment analysis and how entities are used in context, the sentiment of the particular entity, which is extremely important when you're analyzing user feedback or comments that people have left on social media, especially when it comes to your service or your product. And it's also extremely easy to use with multiple different integrations possible. You can use it in Google Cloud, in Google Sheets for people that are not as tech savvy. Of course, you can use it with Python, JavaScript, and so forth. There is very well built documentation for this API. When it comes to the limitations of using this API, the only thing that I can actually say here is that there is overstuffing of the entities that are recognized. So for instance, it will pull the singular and plural forms of the entity. Now, that's not always a bad thing. Check out an article by Lydia Infante about the differences when it comes to assessing keywords in singular and plural form, because I think that's very important for SEOs. So that is not necessarily a big limitation, but it might be a limitation when you're dealing with hundreds of thousands of rows of data. Now, let's move on to how GPT-4 performs for entity analysis and text analysis. Now, I personally think that GPT-4, especially for people that are beginners when it comes to the world of machine learning, and they do want to have like a one-off analysis. Of course, ChatGPT is a much easier option to do that kind of analysis. It is very quick, very good for one-offs. You paste in the text, ask what you want the model to do with a prompt, and you can identify entities. There are some limitations when it comes to identifying entities when you're using GPT-4 or ChatGPT, because the model has not been trained to do that kind of tasks. It has some limitations when it comes to syntax analysis as well. The biggest limitation when it comes to this model, and this is something that we are going to talk about throughout this video, is that it's prone to hallucinations. Sometimes it can pull out words or entities that are not actually within your text, and obviously this is very easy to catch when you're doing a one-off analysis, but it can be quite hard to catch when you're analyzing several hundred or even thousands of rows. Another thing is that the entity recognition that it does and the syntax analysis that it does are quite limited. Like I mentioned, the natural language API is trained to do these particular tasks, so the response that you receive from that API is a lot more structured and is a lot more focused for that particular task. With ChatGPT or GPT-4, what you get is a very unstructured response. It is different in the structure each time, and sometimes it can lead to false entities that are recognized. which overall, to conclude the limitation, it's much less scalable and it has a much slower response comparatively to what you get with Google's natural language API. The results are not as satisfactory. So if I have to choose between the two, I would choose Google Natural Language API for tasks specifically like syntax analysis, entity recognition, and sentiment analysis for entities. So now let's talk about something that we as SEOs and digital marketers have to do quite often, and that is grouping text. When it comes to grouping text, there are two main approaches that you can use that are machine learning based, and that is classification and clustering. The difference between the two is that clustering is an unsupervised machine learning approach, which involves partitioning or splitting into groups similar data objects from an unlabeled dataset. Classification, on the other hand, is a supervised machine learning approach, which involves sorting data into predefined categories. You provide the labels, the machine learning model sorts them. Now, perhaps it's best to illustrate the difference between these two approaches with a simple example from the SEO industry, and that way you can understand these two a little bit better before we go on to the performance comparison. Imagine you're working with a list of pages, like your website URLs, and that you want to label pages with appropriate category tags based on the content that you have. In this case, if you have a list of categories, like your client is sure that all of the content is aligned with either one of 10 categories, then you can implement a classification machine learning approach to parse the content and label it accordingly based on the list that your client has provided. Now, let's say, for example, you don't have a list. Your client doesn't know what the content is about. The website is 20 years old, but you still need to parse and categorize the content so that you have a starting point and know which areas are covered more or less. In this case, you can implement a clustering machine learning algorithm to parse the content, understand the key terms, and provide a topic label for it. I actually have a video on topic modeling with LDAs, which is a clustering algorithm, and it's unsupervised. So let's see which projects in SEO you can apply these type of algorithms in, and then we're going to jump into the performance analysis comparison. When it comes to classification, if you have a large website and you want to quickly understand the content of the website, you can use classification to quickly determine the topics that are covered in the content. If you are conducting a content gap analysis or competitor research, you can also do the same approach to categorize competitors' content. Now, when it comes to clustering, if you're trying to group together keywords from a very big keyword universe, clustering is a great approach to do that. And if you're trying to assign topic labels of a website that you don't know what the content is about, you simply scrape the content and apply a topic modeling algorithm that does the clustering for you. Now that we know what classification and clustering are, let's see what we can actually do with Google Cloud on this particular topic. Using the same API that we discussed, Natural Language API, the classification module allows you to classify documents or pages, content within 700 predefined categories, and this is out of the box. These are predictable categories. You can see the list, and the algorithm will provide the classification based on the content. The benefit here is that you have a very controlled training of the model. You have an accuracy indicator, the percentage the algorithm thinks that this content aligns with the label that it is providing. So this is very good if you are trying to have, first of all, a scalable project, scalable output, and a very controlled environment that is very good for benchmarking. And if you have a very big data set with long documents, again, this is a very good model to use for this type of use case. If you don't find any of these labels suitable for the text that you are trying to analyze, the good thing is that you can have a custom training for this model to improve the accuracy. And this could be very useful in situations where, for instance, you have content that is very niche in terms of the domain, like for instance a medical domain, and you have a lot of medically related categories that you don't really find on that list of predefined categories. So these are all the benefits, and now let's talk about the limitations, because there are some. The main thing is that this is a custom trained API and it cannot be used for anything other than classification. So this particular model of the API is a classification model. It cannot be used for clustering. Another thing is that unless you use AutoML to custom train a model, you can't really give a custom list for your categories, and it requires time, and also data to train a custom model. When it comes to GPT-4, the benefits of this model, you can use it to map out information to a label or assign a plausible label. For instance, you have a keyword set and you want to assign an intent label using GPT-4. In some cases, this does work quite well, so you can use it. In theory, you can use it for both clustering and for classification. It's good, again, for small projects, one-offs in controlled environments where you can actually go ahead after the model has provided the output and see whether it aligns with your expectation, and you can actually troubleshoot any errors as you go. This means that it's very good for small projects, it is very cost efficient, and it is very good for beginners. Those are all the benefits. Now let's talk about the limitations of applying a large language model for a task like clustering and classification. First of all, there are scalability issues. It's not suitable for analyzing large data sets or doing long document analysis. The second thing that is very important for a project like this is to be able to have predictable output. And with a large language model, you don't actually have a predictable output because it is generative AI. The results are going to be different every time that you run it, and you also are going to have some sort of hallucination. So even if you provide specific categories that you want the AI to use, it's not always going to stick to those. For instance, if you prompt it to only use one category label, it's not always going to use just one. Direction might not be followed when it comes to classification, and it has limited knowledge when it comes to certain industries and niches because it might not have a lot of training examples within its training data for those niches. What I have noticed is that when you test this on a small data set and you can troubleshoot, it works okay, but when you're working with a big data set, that's not really the correct model to use. And it all comes down to the fact that this is not a model that has been created for this task. So the next aspect where I wanted to test the two models head to head was image SEO. So within the image category, there are a few different tasks where you can evoke the help of machine learning models like captioning and image generation. At the moment, image generation can only be done by OpenAI's DALL-E model, and Google Cloud for now does not really have a comparable alternative. When it comes to image captioning, there is a Google Cloud model called Vertex AI and also another one called Vision AI. Both of these can do image recognition. When it comes to Vertex, the benefits of using this model is that it can be custom trained on a data set, and it is very good for niche data sets and images for specific industries, like for instance in the medical domain for x-rays. It's very good for large scale projects. The limitations of this model is that it has a steep learning curve. It's definitely not able to be used out of the box or quick integrations. The other model, Google Cloud's Vision API, is very good at detecting emotions and faces, can categorize elements from the photo. It can categorize the photo's activity based on labels that it has predefined and trained on. It also provides an estimation of the likelihood that the class assigned matches the image, which is very good for actually being able to self-assess the effectiveness of the model. And it can extract color patterns, it can detect objects, read printed text, and the great thing is that it can also be trained on a custom data set. The only limitation that I have with this model is that it does image classification, it does image recognition, but it doesn't actually generate a free-form caption. I mentioned a number of different benefits of this model, but the actual limitation is that for what we SEOs use image captions for generating alt text and improving the accessibility of websites, that caption is not actually generated from this output of the model. But you can use something like generative AI to apply it as a last step of this kind of process and actually generate the caption based on the data that is the output of this model. So now when it comes to GPT-4, there is a module within GPT-4 that is GPT-4/V that is for vision analysis and visual recognition. That is good for out-of-the-box use. It provides a very detailed and rich caption. What I found here is that it can detect elements from the photo, and it can even identify popular people or locations in the photo that you provide, which is very good, especially if you have a very good customized detailed prompt that you can use. use to avoid potential hallucinations. The only problem is that it's not available via the API yet, and it has limited scalability as a result of that. It requires some fine-tuning of the prompt. It also might require you to re-prompt, so definitely you will need to have a person, kind of like human in the loop system, to evaluate the output of this model. Another area where you can use GPT-4 or Google Cloud's APIs is within content transformation. Content transformation refers to transforming a content format from either a different format or a different length. It is important for SEO because of two main reasons, and that is omnipresence and accessibility. Omnipresence relates to the fact that your brand needs to be accessible in different content formats on different platforms. And this is not only influenced by the customer's desire to find you on different platforms, but it's also influenced by the fact that Google is changing the search engine results page to show different format of content to satisfy users' intent. So one thing to note is that there are spokespeople from Google that have said that when a content exists in one format, and like for instance a video, and then it exists in another format like a blog post, they don't consider that duplicate content, because it's not. It is a content piece in different formats. Another thing when it comes to accessibility is that it allows the customers that stumble onto your content to consume it in the way that they want. Transforming your textual content into audio, for instance, makes it accessible for people with visual impairments or people that have a content preference. They prefer listening over reading. Let's talk about how you can implement text-to-text content transformation in SEO. If you have a high-performing blog post or resource section on your website, but you don't have presence on platforms like LinkedIn, Twitter, or Facebook groups, in this case, you can benefit from growing your audience by turning your long-form content pieces into social media posts that are published by your brand. And this is a very good way to automate content transformation and to improve your organic brand presence on these platforms. Another use case is if you have your email newsletters that have substantial content but they have limited engagement. Now let's talk about the actual performance comparison between GPT-4 and Google Cloud's Vertex AI on text-to-text transformation. So let's start with Vertex AI. The benefits are that it can be prompted to summarize text, although it has a limited output with more creative tasks. And the limitations are that it doesn't really have much versatility. GPT-4, on the other hand, performs extremely well in text-to-text generation. Why? Because it is a large language model and it is generative AI. So this is exactly what this model has been built for. It allows you to create any style of content, and it requires very limited or little preparation to incorporate best practices. For instance, if you are trying to build a social media post, this is something that you can do in the prompt, and then it allows you to actually bulk transform a number of different content pieces into the format that you want. For instance, you want to turn a number of blog posts into LinkedIn posts. It is also very good at summarizing text, at extracting the main insights from text, and it can transform text to better highlight headings and key points. So if you have to choose between one of the two for text-to-text transformation, definitely go with GPT-4 on this one. Now let's talk a little bit about the limitations of GPT-4 and text-to-text transformation. While you can use the API and you can use a number of different approaches within the prompting, you still have to have someone actually going through the output to ensure that it doesn't contain any of those well-known hallucinations that are a telltale sign that you have used generative AI to write your blog post or transform your text into a social media post. It also has a limited understanding of domain-specific jargon without specific training implemented before the transformation step. So this is very important if you're trying to implement this particular tactic in domains that are very niche or require a lot of information being processed in order to understand what the content is about. When it comes to text-to-audio transformation, think about if you have a high-performing blog post but you don't have a presence on YouTube, you can speed run the process of creating a video by automating the process of audio creation, and now you might have a quicker path to building a visual resource as well. Another reason why you might might want to transform your text to audio would be if you have first-party data for your customers preferring audio over reading. People that listen to audio content while driving, exercising, working, or performing other tasks, in which case if you convert your blog post or written content with an audio, you might be able to have a much higher engagement rate with that particular type of audience. When it comes to text to audio transformation, GPT-4 doesn't really have a model for this, but Google Cloud's text-to-speech API is the perfect API that you can use for this task. It can do different voices and customizations, including customizing based on a certain dialect, which is very important to making sure that your audio sounds convincing and doesn't really sound automated. It is very versatile and scalable. The only limitation with implementing this API is that the cost that you have for the use can ramp up if you are trying to do this for a very large project. Another area where you can implement content transformation is if you are trying to do transcription of video or audio, in which case here are some examples of where you might want to look into this as a potential machine learning project. If you have a library of high-performing YouTube videos but you don't have a blog, you can speedrun the process by transcribing your most popular videos and turning them into blog posts. You might also have a series of successful webinars or online workshops, or running podcast or interview series. You can also look into turning those into a textual format as well and publishing them on your website. Let's see how the APIs compare. It's quite easy to see who the winner is here because GPT-4 doesn't really do transcription at present. There are some additional plugins that you can use in ChatGPT to help you do this task, but out of the box, you cannot do this with the API yet. When it comes to Google Cloud, they do have a speech-to-text API, which is very, very good and advanced at doing speech recognition for accurate transcriptions. And it also handles a variety of languages and accents very efficiently. It also has different models that are specific for videos or phone calls or command and search audios. So the only limitation here, again, is that the cost can ramp up with scale. It will be easier and cheaper to do this with machine learning as opposed to a transcription agency, and it might even be more ethical to do so, but it might still be very costly for people that are working with a tight budget. There is a bonus section in the Search Engine Land article that discusses content localization and specifically translation, how you can use it in SEO, and also the comparative analysis between GPT-4 and Google Cloud's API equivalent on translation projects. So definitely check out the blog to see this particular section. So let's recap what we learned in this session. I think if there's only one takeaway that you go away with and think about as a result of watching this video, it should be that there is a large pool of APIs from Google Cloud that you're likely not experimenting with because you're too preoccupied with ChatGPT and GPT-4. And these APIs are likely much better at specific digital marketing or SEO tasks that you are trying to do in your day-to-day work. So don't just use a blanket model for all of your SEO tasks. Instead, try to understand what the task is, what is the data that you're trying to work with, how scalable do you need the API to be, how it has been trained, and all of these other good things that are related to more technical aspects of machine learning. I've not only highlighted different tasks that you can use these APIs in, but also how utilizing automation in certain areas of SEO can actually benefit your strategy. Incorporating APIs and SEO automation can help you skyrocket the speed with which you get from data to insights. It can improve the quality of work that you are doing, especially when working with large enterprise scale websites or big content libraries, regardless of the format that they are in. And it can also help you grow as a consultant and improve your skill set. Each model will have benefits and limitations. Hopefully this video has shown you just that, and which is why it's important to research what the model that you are using has been trained for and what is its ideal use and purpose. To summarize the performance of GPT versus Google Cloud's API library, I will put the results of the comparison on the screen. Currently, there are some tasks that neither of the two can perform, but as we know, with the speed of development in machine learning, this can soon change. So I hope you found this video useful, and I hope you have learned some new things. Hopefully I have inspired you to start utilizing machine learning more in your SEO work. And I just want to say one more time, thank you for Search Engine Land publication for allowing me to create this resource and publish it on their platform. Definitely go check out the blog post. Thanks so much for watching, and stay tuned for more.